Hi everyone, we are going to start and go through some of the notes today for section 5.5 day 2, so you should have the note sheet out in front of you that I gave you during class. And like I kind of explained to you in class, my main goal behind doing this is to have you be able to walk into class with a little bit of a background about the topic and what we're doing so that we can really dive right into it and hopefully give you lots of time in class to practice this and to know, based on the wording of a question, what is it asking for and things like that. So as I go through this, I want you to be filling in the notes. And then, if you have any questions, you can ask in class. And we'll go through a few examples together before giving, time to work. So for the target, you may have already been writing this down as I've been talking, but there's two topics here. One is synthetic division, and then the other is solving by grouping. And we're going to do the synthetic division in the video, and solving by grouping is actually going to seem very easy after some stuff we did earlier this year, and we will do that together in class. So the first two theorems that I put at the top here are a review of ones that we did when we were doing long division. So the first one just, is a little bit of a recap here. Says that if we take some polynomial and divide it by a factor, whatever our remainder is equal to the function value at k, where k would be, the solution of whatever that factor is. So that's why we were able to use long division to determine if something was a factor, because if we got a remainder of 0, we knew that that factor went in evenly, and let's say it was x minus 5, and if that went in evenly, that would mean that x equals 5 was a solution or a 0, which leads us into this factor theorem, saying that you are only going to get a factor if the value has a function value at 0, and when you divide it, you get a remainder of 0. So that's kind of how this all plays in. Now, synthetic division is really just, and I want you to write this down here, it's a shortcut for long division. And just like with synthetic substitution, we saw that that was a lot easier. I know some of you kind of took a little while to figure out exactly how it worked, but it's going to feel very similar, and it is a shortcut. Now, you can only use it in certain cases, and you can only use it when the factor's coefficient of x is 1. So just a couple of examples here. If we're dividing by something like x plus 5, that's fine. The leading coefficient there is 1, 1x. We can use synthetic division. We could have x minus 3. That would work. Even x plus 1/2. And this one gets kind of interesting, and we won't work with that as much in Algebra 2. You'll do a little bit more in pre-calc with the fractional ones, but as long as that leading coefficient is 1, it'll work. Things that you could not use synthetic division for would be something like 2x plus 7. So because of that 2 there, we would have to use long division. 3x minus 5, we couldn't use it. And we also can't use it if we're trying to divide by something like x squared plus 1. So really, when you're deciding, can I use synthetic, you're looking for just an x with a coefficient of 1. Okay, so in the first example here, I'm actually going to do long division with you first and then show you how synthetic division ties in. And this will be a good practice for what we did with the long division as well. So I wouldn't take up too much space, but try to squeeze this in as best as you can on your notes there. So we're trying to decide if x plus 2 is a factor. If it is a factor, it means that the remainder will be 0 when we divide. So I'm going to start with 3x cubed minus 4x squared minus 28x minus 16, and we're dividing it by x plus 2. Okay, remember that you're always looking at your first term. So I'm saying, what would I need to multiply x by to get 3x cubed? And I would need to multiply it by 3x squared. So then I multiply down. 3x squared times x is 3x cubed, and 3x squared times 2 is 6x squared. And then in long division, I'm subtracting. So that's going to become a minus, that's going to become a minus. Those will cancel, and I will get negative 10x squared, and then the rest comes down. Okay, so then again, I'm looking first term here, what do I need to multiply x by to get negative 10x squared? I would need to multiply it by negative 10x, and then I'm multiplying down. So negative 10x times x is negative 10x squared. Negative 10x times 2 is negative 20x. Subtracting, so that becomes a plus, that becomes a plus. That cancels, and I get negative 8x minus 16. So we're looking, what do I need to multiply x by to get negative 8x? And I would need to multiply it by a negative 8. And then I would multiply down. So negative 8 times x is negative 8x. Negative 8 times 2 is negative 16. I'm subtracting, so that becomes an addition, and that becomes an addition, and I get a remainder of 0. Now, what that tells me is, yes, x plus 2 is a factor, and x equals negative 2 would be a 0 or a root or a solution of this equation if it was set equal to 0. Okay, so we're going to leave that, and we're going to go through the process of synthetic division. So this is the exact same problem. Now, the setup is going to look identical to what we did when we did synthetic substitution. And what you want to be thinking about here is I give you this factor x plus 2. We want to think about what would be the solution of that factor, and the solution would be x equals negative 2. That's the number that we want to put in our box here, just like we did for synthetic substitution. And then we're going to list our coefficients, starting with 3, and that's coming from right here, and then negative 4, and then negative 28, and negative 16. And again, if I was missing, some term like an x squared or an x, I would put a 0 in its place just like we did before. Okay, this process is not going to feel any different, so we bring the 3 down. 3 times negative 2 is negative 6. Add those together, you get negative 10. Negative 10 times negative 2 is positive 20. Add those together, you get negative 8. Negative 8 times negative 2 is 16, and then we get 0. Now, before, all we cared about was that last number, and that was, what the function value would be when negative 2 was substituted in. Well, that ties in here because that really means that negative 2 is a solution, and that means x plus 2 would be a factor, and this last number now is really going to represent our remainder. So right away we can say, yes, x plus 2 is a factor. Now, just to kind of show you how this helps us and does the same thing that long division does, I want you to look at these numbers right here, and then let's scroll back up to the long division, and those are exactly the same numbers as we get as the coefficients there. So that's, what this will tell us, and this would say if we were to take 3x cubed minus 4x squared minus 28x minus 16 and divide it by x plus 2, having an x cubed divided by an x, this number right here would be 3x squared minus 10x minus 8 with a remainder of 0. And then that would be times that x plus 2 if we were trying to break it down. And then, if we had to, we don't need to for this problem, we could try to factor that 3x squared minus 10x minus 8, solve it, depending on what the question said. So let's try another example. Okay, so number 2, we're trying to determine if x equals 3 is a root. And remember that root really just means a 0 or a solution. Now, in this one, they gave us what that actual solution is. So that can go right in the box here. If we had to come up with the factor, that would be x minus 3. And we can do that later if needed. So we're going to list our coefficients, which are 2, negative 11, 3, and 36. Okay, so the 2 comes down. 2 times 3 is 6. Negative 11 plus 6 is negative 5. Negative 5 times 3 is negative 15. 3 minus 15 is negative 12. Negative 12 times 3 is negative 36. And we get 0. And remember that that last number there is now our remainder, which means that, yes, x equals 3 is a root. And really we've answered the question, but just to kind of show how this all ties together, if x equals 3 is a solution, then x minus 3 would be a factor, and these numbers right here give us what our quotient would be when that division happens. So it would be 2x squared, because we started with an x cubed, minus 5x minus 12. And then if we needed to, we could keep going with that. Okay, we're going to do one last example together, and I'm actually going to let you do this one a little bit on your own and then check your work. So in this one, the wording is the same as with long division. It's just that now we can use synthetic division, because if they tell us that negative 2 is a 0 or a root, that means that x plus 2 is a factor, and that x has a leading coefficient of 1, just like we talked about at the very beginning in those boxes there. So let's go through and get the synthetic division set up, and then I will let you pause the video and try it on your own. So we're going to put negative 2 in the box, and then we're going to list our coefficients. So 1, 2, negative 9, negative 18. Okay, so what I want you to do is pause the video here, go through the synthetic division process. We know that we should get a remainder of 0, and then I want you to give me, so we know x plus 2 is a factor, and I want you to give what that remaining factor would be as well. So go ahead, pause the video, and then when you're ready to check your answer, you can press play again. Okay, so this is what it should have looked like, and it was good that we got 0 as a remainder. I knew that was going to happen because they told me automatically negative 2 is a 0. Now, we started with an x cubed, we divided it by an x, so that means that this 1 right here is going to represent a 1x squared, plus 0x, which we don't need to write, and then minus 9. Now, it's asking me to find the other roots or solutions, so we're going to set this equal to 0. Well, we don't need to worry about this one because they already gave us negative 2, but we do need to think about x squared minus 9. And we can either set this equal to 0 and solve it using square roots, and you would get x equals plus minus 3. You could also factor it into x plus 3, x minus 3. Either way, you're going to get the same solutions. Okay, so bring this with you to class. We will finish up a couple examples here, and then you'll have the majority of the class period to work and ask questions and work with each other as well. All right, thanks for watching, and make sure to go on now back to the website where you first clicked the video link and fill out that Google form that's up there, and that'll allow me to give you credit for this homework assignment and just to know that you did it.